Welcome to the presentation of the recent improvements that have been made to the process of building OpenAccess. Today we'll briefly recap the difficulty users have experienced building OpenAccess and its extensions, a solution that has been developed to help overcome that difficulty, and then give a quick overview of how this solution removes the difficulty. SI2 has a goal of making OpenAccess easier to use. Building OpenAccess is one difficulty members have struggled with in the past. OpenAccess is a very complex API and database, but it provides incredible power to application developers. There are over 2,000 classes in the C++ reference implementation of OpenAccess. The extensibility of OpenAccess has led to additional source code being written that needs to be built along with the OpenAccess source code. The platform matrix is the world in which OpenAccess is developed and tested. It specifies the operating system and compiler versions that should be used to build OpenAccess, typically one operating system and one version of the compiler for a given version of OpenAccess. It gives us a known good set of dependency versions that will work. Other configurations can be tried given this starting point. The complexity of the build process grows exponentially when also building extensions. Each extension's dependencies have to be synchronized with those of OpenAccess, and compatibility between the versions of each tool and/or library becomes difficult to manage. Members commonly ask for a spreadsheet that shows the interdependencies, but that is not possible as this is a multi-dimensional problem. The SI2 OpenAccess team has developed a solution to this difficulty. A build tool has been developed that uses the industry standard GNU autoconfig to examine a user's build environment, report any missing dependencies or conflicts between versions of third-party tools and libraries, automatically create the config files needed to build OpenAccess and its extensions, and finally to synchronize the build of OpenAccess and its extensions so that the same configuration is used for all. The build tool guides the user through the process of setting up their build environment so that when the process of building the software is launched, it works the first time. Allow me to introduce you to oaBuilder. I have an all-in-one directory that I've downloaded and installed here on a blank VirtualBox, and I'm going to demonstrate how to set up this blank VirtualBox using this all-in-one collection of our software and then build it using the oaBuilder tool. So I've installed the oaBuilder tool, and to launch it, this is the draft version or internal tire kicking version of the tool. So in the GUI, when it initially comes up, there are very few things that can be clicked, or very few options presented that you can change. And that's because the set of things to be changed should be very specifically about taking the first step of setting up the configuration. Under File, you have the option to open a project if you have saved a project. Under Tools, you can use the autofill tool when it's available, which was going to be demonstrated in just a second. And then these three log windows are presented when you run the validate or the autofill. That will show the configure window, and the build log window will show when you start building, and the installation log window will start when you install. The project mode provides the ability to build in either a single configuration or a multi-configuration mode, and sometimes you may need to have one set of configurations for one set of scripting tools and a different set of configurations for a different set of scripting languages. And so you would choose multi-project here, and you would specify the individual saved projects with the configurations in those saved projects. But in this demonstration, I'm just going to use the current project, which is single configuration. And the only other thing that is possible to click on right now is the build directory. The build directory is the directory that contains all the source code. And so let's click on that for this demonstration. And if I try to click on a directory that is not a valid build directory, I get an error message. The directory is not valid. It does not contain the configure script. Okay, so let's pick the right one. So now you see that many more options have been enabled in this GUI, including the validate button at the bottom, and in the middle section, the modules, wrapper languages, and tools/libs tabs, and also the install directory. Automatically, it defaults to installing into a directory named install that's inside the all-in-one directory. But also now we could save the project, which doesn't have much configuration in it yet. We can now have the ability to run this autofill tool, but we don't have any log windows yet because we haven't run the configuration tool or the build or install processes. The next thing we want to do is run the autofill tool. So this will automatically search your environment and report to you the things that are not present, if there are any, in your system. And that was very quick. And here's the report for my system. There are several things. This is a brand new VirtualBox. So the GCC, Python 3, Tcl, Tcl-devel, Flex, Bison, M4, Patch, libc, Boost. These all are absent from this VirtualBox by default. And some of these I can add into my system using yum install, such as here for Python 3, the native version of Python 3, which is 3.6.8 on a Red Hat 7 system, is compatible with building OA and its extensions on Red Hat 7. But there are some that are not compatible. GCC native version is not, so we need to get 9.3. And for those, we'll go to the members portal and we'll go to the ESG downloads section, which is here. And then we'll go to the documents. And in here, we have a Red Hat 7 GCC 9.3 build tools directory, which contains many things that have been precompiled and can be used to build OA and the extensions, including GCC and many of the different scripting languages and Clang as well. So let's go through this. Okay, so we need to download GCC, and that is one which I cannot install using yum. So I'll download GCC, for example, here by clicking on that and then hitting the download button, and then that'll download. While that's downloading, I'm going to get another terminal window ready. Okay, so I'm going to need to set up my bash RC file to include GCC and add it to my path and also the library, LD library path for GCC. This is one of the things that is needed as well, the LD library path. So that's nearly finished. But in fact, I've already downloaded it prior to this demonstration, so I may not download it. I'll just use my pre-downloaded versions for this demo. So to add this onto my system, I'll go to I have to become root. So I like to install here in the opt directory, and it looks like I've actually already added in GCC 9.3. So in another terminal, I'll make sure I've added that into my bash RC file. Okay, so I have created a variable here, and to export and add that into my path, I'll do that. And to do the LD library path, I need to add in the directory that's lib64 into my LD library path. And that takes care of adding the GCC. The next one on the list is Python 3. And so in this case, I can use yum. So I'll use yum to install Python 3 and Python 3 devel. All right, so now we're going to restart oaBuilder and the terminal so that all these are brought in. We'll leave the root open. Terminal new window. Which GCC? Very good. And let's see which flex, for example. Yep, it's finding them. Okay. Go back to my home directory, and we'll restart the oaBuilder. Again, the only options we can specify are the very first step that we need to take, which is to specify which directory is our source directory, a build directory. So let's specify that. And now I'm going to rerun the autofill tool, and hopefully we'll have fewer things that are missing. Perfect. This looks like, well, this is the next step. So everything that we just did was done correctly, and it found everything, but now it's telling us that we have selected oaScript and some other extensions which require these scripting languages to be specified, and they're not. So that's the next step. So let's just specify one version of each of these, and those I will need to download from Portal. So I'll download a version of Python 3.10, a version of Ruby 3.04, and a version of Tickle, the 8.6.13. So we'll go back to our oaBuilder, and we'll specify those. Going to the opt directory, and we're specifying the Python executable. So we got to go into bin and get Python 3 executable, Ruby. And if you do happen to try to use a Python executable for Ruby, they'll tell you that's not a Ruby interpreter. Ruby. Ruby executable. Okay, and Tickle. Tickle. Also, I know this is going to occur. If we try to validate this now, there are going to be some error messages about Swig because we didn't specify those. But at least yeah, so it says Python scripting languages were specified, but Swig was not enabled. So we need to turn that on. Okay, so we need to turn Swig on by saying build the macros. Now we need to specify an installation of Swig and Clang, which are needed in order to build oaScript. And so I'm going to download those also from the portal, Clang and Swig. Okay, and I will need to add those also into my bashrc file so that it finds the correct version. Clang. And Swig. And add those into my path. And we'll restart again. Now it sees Clang. That's good. And Swig as well. Okay, so now let's start oaBuilder. So it brought us all the way back to square one. And this time, after doing these initial setup things, I'm going to save the project. So we have to specify the build directory. We're going to run the autofill, and we're going to specify some wrapper languages. This is Python, Ruby, and Tickle. And we're going to turn on Swig, add the version of Swig that we just installed. And Cling. Okay, so at this point, I'm going to save the project so that we don't have to do all that again. And I can put that into the all-in-one directory. Demo big suffix proj is not required. You can just leave it blank like that if you want, but I like to use the suffix so that it reminds me that's what that file's about. So it saved a bunch of stuff. So if we were to start over now, we could actually go up and open the project. Open project. Okay, so now let's test this, validate. And we have success. Configuration has been completed successfully. So now the build button becomes active. And at this point, we would click build, and it would begin to build def, OA, then oaScript, and all the extensions. Now that the build has completed, we can go to the install button and click the install, and it will create the directory and the installation. So it installed OA, oaScript, oaXcolor, all of them to OAT debug, and it finished. So we can close that. And now we should see a new directory, install. And in there are all of the modules, def combined into a single module, and each of the others. In summary, the process of building OpenAccess and its extensions is very complex. oaBuilder greatly simplifies this process. In addition, the ability to launch a build and have it succeed the first time minimizes CPU usage, which in today's cloud-based pay-per-use saves not only time, but money. And finally, oaBuilder guides users through the process of setting up their build environment and makes the task of building OpenAccess, its extensions, and any proprietary modifications a piece of cake. Thank you.